Hello again, it's Miss Hicks. We are going to talk about derivatives today. Not surprising. And I really hate that I'm going to miss seeing your actual little faces when I show you this rule because it is about a million times easier than what we've been doing. And people are either happy that they get to use the rule or they are furious that they had to do it the long way. But we have to do it the long way because we need to know what it means. And we don't understand what things mean if we're doing them shortcutty ways. Okay, so before we get started, this is not on your notes. I want to just go back in time a little bit. And here's a problem from the 3.1 worksheet. Okay, we had a problem. It said h of x equals 3 minus x squared. And we were asked to use the original definition of derivative to find the derivative at x equals -2, or it said a equals -2, but either way, whatever. So let's do that. So we would have h prime of x equals, now remember, this is the f of a plus h minus f of a all over h. So what would we have? We would have 3 minus a plus h squared. So that's f of a plus h minus 3 minus a squared all over h, which is going to, oh gosh, what did I forget? The limit as h approaches 0. So once again, we're going to have the limit as h approaches 0 of 3 minus, let's see, I'm just going to square all this, a squared plus 2ah plus h squared minus 3 plus a squared. I hope I'm doing this right. I'm not looking at it on paper, and sometimes going from MacBook to Mimeopad back and forth and paper is, I mess things up a little bit. So hopefully I'm doing it right. Let's see. That's going to be 3 minus a squared minus 2ah minus h squared minus 3 plus a squared all over h. Let's simplify a little bit. Limit as h approaches, 0. Let's see, the 3 and the -3 cancel. The negative a squared and the positive a squared cancel. And I can pull an h out. So I'm going to go ahead and do that. I'm going to have h, and then I'll have -2a minus h all over h. Do you see what I did? I took that h out right here. These can cancel. I can substitute in h approaching 0, and my answer is -2a. And I was asked to find the value when a, or x, is equal to -2. So my final answer is 4. Do you agree? All right. So final answer of 4. Well, do you happen to notice a pattern? Do you see this -2a? Look back up here at our original function, okay? Before we even substitute it in, that's not really part of what I want you to see. I want you to see that we went through all this trouble to find h prime of x, and we found -2a. What if we called that x? That would be -2x was our derivative. We could say that h prime of x is equal to -2x. How did we get -2x from this? Take a second and look at it. Think about maybe where the 2 came from, maybe what happened to the 3, maybe what happened to the x squared. And just kind of think, see if you can see a pattern, okay? I was going to see if I could come up with another example real quick. We had this problem on 3.1. 3.1 on the notes. We had the problem that said f of x equals x cubed plus x squared. And we went through all the limit stuff. You know, it was a long, long problem. We went through the limit stuff, and we found that the derivative was equal to 3x squared plus 2x. Do you see any pattern here? 3x cubed plus x squared, x cubed plus x squared, and that turns into 3x squared plus 2x. Okay, well, that's what we're about to talk about. We're about to talk about a major super shortcut that is going to help us take derivatives. and you're going to like it, I think. I think you're going to like it. All right, let me grab my notes. Hang on one second. Make sure my notes go along with the PowerPoint here. All right, the first thing we're going to do is talk about the derivative of a constant. If you have a constant, so for example, if you are given y equals 5, perhaps, something like that. What does that look like on a graph? Well, it looks like this. What is the slope of the tangent line of that? It is 0. So therefore, the derivative is 0. Hopefully that makes sense to you. Here's the question. If f of x equals 5, which is the same thing I just wrote, y equals 5, find f prime of x. Well, that is going to be equal to 0. The derivative of any constant is equal to 0. That's what this says right here. The derivative, d dx, that's one of the ways we write derivative, of a constant is equal to 0. All the time, every time, no matter what. You don't have to go through the whole limit mess. You can if you feel like it, but you don't have to. That's what happened right here when we started this problem. I said h of x equals 3 minus x squared. That's why this 3 right here went away, because the derivative of 3 is the derivative of a constant, and the derivative of a constant is 0, so it went away. It did not play in the answer here at all. In fact, you could think about this answer as the h prime of x is equal to 0 minus 2x, if you wanted to think about it that way. All right, let's look at the next rule. That was rule number 1. That was the derivative of a constant. Rule number 2 is the power rule. This is the biggie. Like, you should kind of jump up and turn around a few times before you get this one. All right, the power rule. The power rule says if n is any number, then the derivative with respect to x of x raised to the n power is equal to n. So notice the exponent comes down into the front as a coefficient, times x to the n minus 1 power, provided x to the n minus 1 exists. So if you end up getting, this is 0, it's not going to work, but we'll talk about that in a minute. Get this out of the way here. There we go. The key to using the power rule is to get comfortable using exponent rules to write a function as a power of x. Very true. I told you maybe 3 sections ago that we were going to be doing a lot with exponents, and that is absolutely true for the rest of the year. So let's look at this. Let f of x equals x to the 5th. Find f prime of x. Well, using this rule that we have right here, our f prime of x would simply be equal to, what happens? The n, the exponent, comes down and is our coefficient in front, so that 5 is now in front, times x, here we are up here, to the n minus 1 power. So we're to the 5 minus 1 power. What does that give us? That gives us 5x to the 4th. Go back. We're going to look, I'm going to go back a couple pages to this very beginning problem. Do you see that the 3 went away because it's a constant? We take the derivative of constant, we get 0. Negative x squared, when you take the derivative of negative x squared, the 2 comes down in front. The minus sign is still there. Negative 2 times x to the 2 minus 1 power is the same thing as to the 1 power. So we followed the same rule that we're learning right now, the power rule, but we found it all the way through the limit problem. Same here. If you find the derivative of x cubed plus x squared, you get 3x squared, which is the exponent comes down, is the coefficient, times x to the exponent minus 1 power, so 3 minus 1 is 2. And then same thing here, plus 2x. That's the same thing here as the 2 coming down in front and 2 minus 1. All right, maybe this is making sense to you. I hope so. So we are not anymore going to be using the long definition of derivative, the limit thing. You will have to know how to do it. It will still be it will still show up on tests and such. It will still be on the AP exam. You got to know the definition of a derivative by limits. You have to know the definition of continuity by limits. But when you're asked to find a derivative, you just simply need to do it this way. Now there are many other rules involved with this. We're just going to learn a couple of the super simple ones today. All right, let's look at example 3. Let f of x equal the cubed root of x squared. Find f prime of x. Well, this is one of those times when you really need to understand exponents. So what you want to do first is you want to rewrite the problem. Okay, instead of the cubed root of x squared, we want to think about this as x squared raised to the 1/3 power. Do you believe me? I hope you believe me, because I think you know that the square root of, I don't care, some number, is equal to that number to the 1/2 power. Do you remember that? Okay, well the cubed root is equal to the 1/3 power. And that makes sense if you think about the cubed root. Cubed root and squared root. This is the root here to the 3rd power. I don't know. It makes sense to me. Maybe that was too much. Let's see. Go back here. Okay, so we still haven't found the derivative. So we just have f of x is equal to x squared to the 1/3 power. Now we need to write that one more way, because right now we don't know how to deal with these parentheses. We don't know how to deal with an exponent raised to another power. So we just need to simplify just a little bit more, and we're going to have f of x equals to x. Now how do you get rid of the parentheses? When you have an exponent raised to another exponent power, you multiply them. Sound familiar? I hope so, maybe. Okay. Now we are ready to take the derivative. Now we are ready. We've got it as simple as we can get it. So x to the 2/3, when you take the derivative of that, the 2/3 comes down front is the new coefficient, times x to the 2/3 minus 1. How do you do that? Well, this is fractions again. Fractions, exponents, all that. That's the same thing, and we'll come up here as 2/3 minus 3/3. What does that give you? It gives you a negative 1/3. Negative 1/3 power. Now, this is a perfectly legitimate answer. You can leave it like that, right here. If it bugs you, you can change it. I will say you might want to get over it if it bugs you, because this is definitely the easiest way to move forward, is to have a negative exponent like this, a negative fraction exponent, perfectly legal. And definitely simpler. You could also rewrite this as 2, oh gosh, there's so many ways you could write it. You could say 2 to the negative, or 2 to the x to the negative 1/3 power over 3, or you could say 2 over 3 times the cubed root of x. Oh, just many, many ways you could write this. Let's look at example 4 here. Example 4 says, let f of x equals 1 over x to the 4th. Find f prime of x. Okay, I'm going to run out of room here. Let me see if I can just real quickly grab this. Copy, new page, paste. Oh, I did it. Yay. All right, there's some extra room. Here we go. Let f of x equals 1 over x to the 4th. Find f prime of x. Okay, well, right now we have a fraction, which means we have a denominator, and we don't really know how to deal with that as of yet. So we need to rearrange our problem here to look more like the rule that we do know how to deal with. So instead of 1 over x to the 4th, I'm just going to call it x to the negative 4th. You know this. You know when you move a denominator up to the numerator, all you have to do is change the sign of the exponent from positive to negative. I know you know that. So now we're ready. That's all we had to do. Now we're ready to take the derivative, okay? So we'd have f prime of x is equal to, now, how do you do it? This number here, the exponent becomes the coefficient. X stays the same. Negative 4 minus 1. The original minus 1. What is that going to give us? It's going to give us negative 4 x to the negative 5th power. That is a very good perfectly legitimate answer. If you must rewrite it, if it just drives you crazy, you can write it like this. It doesn't matter. I kind of think this one is going to be better going forward, but the best thing to do would be to know that both of these are perfectly equivalent. All right, let's look at another problem. The constant multiple rule. All this says is if u is a differentiable function of x, so you have a differentiable function, a function that can be differentiated, and if c is a constant, then the derivative of the constant times the function is simply the constant times the derivative of the function. When you see this, du dx, that means the derivative of u with respect to x. Okay? The derivative of function u with respect to x. That's what that means. Let me erase so we can see the c. There we go. All right, so when we start off doing this, we're going to pull the constant, the c, out front, but it's certainly not something we're going to do forever. It's just a shortcut we're going to, or not a shortcut, it's a method we're going to do for a while just until we memorize the rule. Okay, so let y equal 5x to the 7th, find dy dx. That means find the derivative of y with respect to x. That is the same thing as if I gave you f of x and said find f prime of x. That's the same thing as if I said here's y, find y prime. There are probably about 5 different ways to write a function in derivative notation. This is just one of them. All right, so how do we do that? Well, I'm going to think about it like this. 5 times x to the 7th, okay? I'm going to kind of leave the 5 out front. Now, y prime equals, well, the rule here tells me that I can take the constant, just leave him there, and then find the derivative of the function. Well, what is the derivative of x to the 7th? Hopefully by now you can see really quickly it's going to be 7x to the 7 minus 1 power, which is 6. So 7x to the 6th power. Now, simplify. There's no reason for these parentheses. I know what 5 times 7 is. 5 times 7 is 35. So my final answer for the derivative is 35x to the 6th power. Can you just say, when you bring the 7 down here, 7 times 5 is 35? Yes, you can. It's the same thing. I just want you to see where we're getting this from. Okay, let's look at the next one. Let g of x equals 4 over 5x cubed. Before we get started, we need everybody that we can get into the numerator. So I'm going to change this to be 4 over 5. Whoops, I didn't do what I wanted to do, did I? I did not. I drew my line wrong. This is going to be 4 divided by 5. And then the x cubed I'm going to bring up here and say x to the negative cube. So take a second, make sure you believe me that this is the same as this. Now I'm going to rewrite it one more way. I'm going to use the 4/5 as just a constant. You okay with that? I hope so. Let's move on. So now I'm ready to take the derivative. So g prime of x is going to be 4/5 times my derivative of x to the negative 3 power, which is going to be negative 3 x to the negative 3 minus 1 power. What does this give me? That gives me negative 4. So now let's get rid of the parentheses and just multiply out a little bit. I'm going to have negative 12 because 4 times negative 3 is negative 12 divided by 5 times x to the negative 4th power. Many ways you can write that. If you want to write, let's see, you could do negative 12 over 5x to the 4th. That would work. I just worry that the more we move the exponents up and down, the more we are likely to mess it up. So this is a perfectly good answer. I kind of recommend you leave it like that. But some of you probably really hate that and just refuse to leave it that way. So whatever floats your boat. Let's look at the next problem. Sum and difference. Sum and difference is adding and subtracting. adding and subtracting, not multiplying, not dividing. We are not going to learn multiplying and dividing of functions when we find derivatives until next time, okay? This is adding and dividing, not multiplying. So what do we do here? If you have two functions, u and v, in calculus we always use u and v as the functions in rules. I don't know why. They just picked a u and a v, and that's pretty much what you see from here on out. So if we have a function u and a function v, and they are added together, you can find the derivative of them separately. And just, if they were added before, then they're going to be added in the answer. If they were subtracted before, they're going to be subtracted in the answer. All right, that's all this says. So how would you find this derivative? Well, you just do it separately. You follow this part right here, du over dx plus or minus dv over dx. That just means you find them individually, and then you can, at the end, add or subtract them together to get your final answer. Okay, so if y is equal to x cubed plus 4x squared minus 2x plus 7, what is y prime equal to? Well, we just do them one at a time. What is the derivative of x cubed? It's 3x squared. Now, we have a plus here, plus. What is the derivative of 4x squared? It is going to be, do I need to work this out where I pull the 4 out front? Or can you just recognize by now that it's going to be 4 times 2, which is 8. X to the 2 minus 1 power is just 1, so I'm just leaving it like that. Notice the powers are decreasing each time. This was a third, now it's a squared. This was a squared, now it's just a single x. Okay, let's keep going. Minus 2 times x to the, now what happened here? That was x to the 1 power. The 1 came down here and got multiplied by the 2, but now it's x to the 1 minus 1 power, which is x to the 0 power. What is x to the 0 power? What's any number to the 0 power? It's just 1. So what we really have here is just a negative 2. What happens to the 7? When you take the derivative of 7, what do you get? The derivative of any constant is 0. So what's our answer going to look like? It's going to look like y prime equals 3x squared plus 8x minus 2. That's our answer. If you're feeling really excited about this right now, why don't you take this big, yucky, nasty thing here and go try to plug it into the definition of derivative, the limits, and see if you can get the answer to look the same. It may not really work because there's a cube there, and the cubes are really difficult with the algebra, but you know, if you're bored, you can go try. All right, let's look at the next one. Example 8. Let g of x equals 3 over negative 2, blah, blah, blah. Okay. Well, the first thing we need to do is do a little simplifying, okay? So I'm going to rewrite it. G of x equals. Now, I guess I really just would like to get rid of the parentheses here. So I'm going to have 3 over. Now, negative 2 raised to the 4th power. What is that going to give me? Let's see. That's going to give me negative 2 to the 4th power. Well, that means negative 2 times negative 2 times negative 2 times negative 2. So that's going to give me, let's see, 4 times 4 gives me 16. And it is a positive 16. So I have 16 times x to the 4th. Minus x over 2 plus 1/4. Let me erase all this mess right here. A lot of different ways you could have done that too. I hope you know what negative 2 raised to the 4th power is. All right, so I need to simplify a little bit more. I got 3 over 16 times x to the negative 1/4 power. I'm bringing him up to the numerator. Yes, you can just write it the way I did. Yes, you could have continued your line out and written it like this. Either way works. I prefer having the variable kind of sitting by himself, but they're exactly the same mathematically. Doesn't matter to me which way you write it. Okay, so to continue on here, we got 3 over 16 times x to the negative 4th minus, I'm going to change this and just call it 1/2 x. Do you agree that that's the same thing as this? plus 1/4. Now I'm ready to take the derivative. Okay, so g prime of x is equal to, I'm going to have 3/16 times -4, that exponent comes down and is the coefficient, times x to the, what is that going to be? -4 minus 1 power. That's a -5 power. Minus 1/2 times x to the 0 power, right? Which means 1, so that it goes away. It doesn't become 0 itself. It's just the exponent is 0, so the x goes away. Now, what's the derivative of any constant? It is 0, so there's nothing there. So we're done. Let's simplify our answer a little bit because it's pretty messy. Let's see, I would have g prime of x is equal to 3 times -4. What is that? -12 over 16, x to the -5th power minus 1/2. Let's see if this simplifies a little bit. Does 12 over 16 simplify? It does. 4 goes into both of those. 4 goes into that 3 times. 4 goes into that 4 times. X to the -5th minus 1/2. I would leave my answer like that. If you want to rewrite it, again, you could write something like this. I just have a tendency to mess it up when I start moving exponents to the numerator and denominator. All right, let's see. Find the equation of the tangent line to the function f of x equals 4x cubed minus 6x plus 5 when x equals 2. Well, on the test we just took, or we took last week that I just graded a couple days ago, this was a fairly long problem because you had to use the limit definition and then substitute in all that. So let's see how this works. And it's a cubed function, so I probably wouldn't even have given you that one because it's ugly, but let's just see how easy this is going to be now that we have our derivative rules. So if we start with the function f of x equals 4x cubed minus 6x plus 5. I need an equation of the tangent line. Well, to find an equation, you need a point and you need slope. Okay, how do you find a point? Well, I gave you part of the point. I gave you x equals 2. So let's try to find the y value. So we need to look at the original function. So f at 2 is going to give me 4 times 2 cubed minus 6 times 2 plus 5, which is going to give me 4 times 8 minus 12 plus 5. I'm doing this all without my work having been worked out in front of me, and you know I'm going to mess something up, but I'm trying. Let's see, 4 times 8 is 32 minus 12 plus 5. What does that give me? 32 minus 12 is 20. 20 plus 5 is 25. So my y value is 25. Now, how do I find slope? I'll write that down one more time. How do I find slope? Well, slope is derivative. Slope is derivative. If you have not memorized, if that doesn't sink in yet, you need to go back and look at it some more. Slope is derivative. Derivative is nothing but the slope of the tangent line to the function at some point. So how do we find slope? We find the derivative. So we need f prime of x. F prime of x. Now, f of x was 4x cubed minus 6x plus 5. How do we take the derivative of that? Well, the 3 is going to come down. It's going to get multiplied by the 4. We're going to have 12x to the 3 minus 1 power is 2 minus, what happens? What's the derivative of negative 6x? It's just negative 6. What's the derivative of 5? It's 0. We don't even write it. This is our derivative. Now we needed the derivative at x equals 2. So now we plug in a 2 here. This gives us 12 times 2 squared minus 6, which is equal to 12 times 4 minus 6, which is equal to 48 minus 6, 42. What is 42? 42 is the derivative at x equals 2. Well, that's the same thing as the slope. So the slope of this function at x equals 2 is 42. How will we write the final answer? We'll write it in the form of y minus y1 equals m times x minus x1. And so it's going to look like this. Y minus 25 equals slope times x minus 2. There's our answer. A lot less work than was required about 3 sections ago. Let's look at the next problem. Let h of x equal x squared plus 1 over 2x plus 5. Let me take a second and just make sure that my problems are following along with your problems. Exactly. They are. Good. Okay. All right. So how do we do this? Well, we mentioned here that we were only learning how to do sums and differences, functions that have sums and differences, not functions that are multiplied, not products and quotients yet. We'll get to that next time. But for now, we need to change this right here away from being a product. Right now it says x squared plus 1 times 2x minus 5. We don't know how to deal with that yet. It gets a little messy and we don't have a rule for that quite yet. So how can we turn this into nothing but a sum and difference problem? Well, all we do is multiply out. All we do is FOIL it out. So we would have, if you have x squared plus 1 times 2x minus 5 and you FOIL that out, you would have, let's see if I can do it, 2x cubed plus 2x minus 5x squared minus 5. First, I don't think I did it with first, outer, inner, last. First, outer, inner, last. Did it a little bit backwards, but it works. Can I combine anything? No, there's nothing to combine here. I will go ahead and rewrite it, though, to where it kind of goes in order. So I have 2x cubed minus 5x squared plus 2x minus 5. All right, I'm ready to take the derivative because I have nothing but sums and differences here. Absolutely no products and quotients between parts of my function. Okay, so what's the derivative of 2x cubed? I'm waiting. Did you get it? I hope so. 6x squared. What is the derivative of minus 5x squared? Minus 10x, negative 10x. What is the derivative of 2x? It is simply 2. What is the derivative of negative 5? It is simply 0. This is our answer. That's it. That's all we have to do, okay? I hope that you are truly getting how great and easy this is, and yet what it all means based on the difficult stuff that we learned before. So in this case, think about what we have here. In this case, we have a pretty fairly complicated original function, 2x cubed plus 2x minus 5x squared minus 5. And we found the derivative. Even the derivative is a pretty, I mean, it's not a complicated function, but it is a parabola, right? So we're moving away from derivatives that are just simply a straight line into derivatives that are now a curve themselves. Let's see. Number 11, example 11. The volume of a cube with sides of length s is given by v equals s cubed. Find dv ds. That means the derivative of v with respect to s when s equals 4 centimeters. How do we do this? Okay, so, I was thinking for a second in my head that this was the extra credit on the test, but it's not exactly the same. All right, so how do we do that? Well, we've got v equals s cubed. We are told to find the derivative of v with respect to s. That means essentially, you're just finding v prime, okay? You can write it however you want, dv ds. Normally, think about it, we find the derivative of y with respect to x. You have y's here and x's here. Well, this works just as well. It just means on our axis, instead of an x and a y axis, we have a v and an s axis. Okay, so dv ds. How do we do that? all we say is, okay, if v is equal to s cubed, then dv ds is equal to, what's the derivative of s cubed? It's simply 3s squared. Does that make sense? Maybe. The exponent comes down as the coefficient. The new exponent is 3 minus 1, which is 2. Now, how do we find dv ds at, s equals 4? Well, that is going to be 3, substitute in your s, squared. What does that give us? 3 times 16. What does that give us? Let's see, 3 times 6 is 48. All right, there's our answer. Think about the question. Think about what this told us. The volume of a cube with sides of length s is given by this. What are we finding here? We're finding the rate of change of the volume with respect to the side length when the side length is 4. So here's the volume. If the volume and the side length are changing, what is the volume when the side length is 4? That's what we found. All right, let's see. Do we want to use this one? No, I don't want to do this yet. All right, we're going to wait on the product rule and quotient rule until next time. Break it up into another video. Okay, that's it for now. That was basically day 1. I think you should have a 3.3. Make sure. Do you hear my dogs? They're going crazy in the house right now, trying to get out. Yeah, you have a 3.3 worksheet day 1. I think. Look at yours. It may not say day 1 and day 2. I'll be more specific about what we're going to do in class, but you should have a 3.3 worksheet, and if you get to any that look like a product or a quotient, we're not going to do those quite yet. Okay, so fill in your notes from this video and come to class ready with questions. All right, I'll talk to you later. Bye. Go do this. Whoops.